So now we have discussed combinational circuits. Combinational circuits. Okay. So under combinational circuits, we have discussed decoder, multiplexer, and encoder. Right? I told you it's easier to understand combinational circuits because output depends only on input. So you have the input, you have the output. So only thing that determine your output is, of course, input and of course your circuit. Okay. So that means for given input combination, always you get the same output. If it is 0, 0, 1, and if the output is 0, 1, it's always for 0, 0, 1, output is 0, 1. Okay, so that is what is meant by combinational circuit. So your output depends only on input. But now we move on to another type of circuit called sequential circuit. Sequential circuit. In sequential circuit, output depends on both inputs and the previous output. Okay. So why is it so? Because in sequential components, the output is also fed as another input. You have your normal input plus your output is also an input. So then it's a sequential component. I told you understanding combinational components are easier. Understanding sequential components are much more complicated, challenging. Okay, much more complicated than challenging. Because you need to think through a sequence. You can't just look at a snapshot and understand what is this. You need to look at few clock cycles and what is going to happen. And then you need to decide, okay, this is the final result. That means you need to think a little bit more seriously. Okay. So therefore, be prepared to do that in this session if you want to understand this. Okay. Otherwise, of course, you can memorize this, but memorizing is not a good thing for, maybe it's good enough for your exam, but not for your career and other things. Okay. Confidence. Right. Under sequential circuits, we are going to look at latches and flip-flops. So other sequential circuit components include shift registers, counters, but we will only concentrate on latches and flip-flops in your syllabus. And understanding flip-flop is super challenging. But understanding latches is not that challenging. It's relatively easy. So therefore today we will only concentrate on latches and you have enough time to think about it then. Okay? Latches. So by the way, what are those things like some funny names like latch, flip-flop? Okay? Maybe you have a little bit of understanding about what is registry and counter, right? Counter is used to count something. Okay? So in order to understand the functionality of these latches and flip-flops, you need to understand the role of computer clock. Computer clock. So computer clock is not for find your time. That is just a software in your machine. Computer clocks, its task is similar to the task of our heart. Heart. What is the task of our heart? It pump, it pumps blood. It pumps blood. So that blood circulate in your body. At the same time, that is one way of looking at the clock. Another way of looking at the clock is if you have seen, definitely you have seen in when there's an opera or something, there's someone conduct the music, band master or whatever, right? I don't know exact name. So he or she is the one that coordinate the music group. So the clock play that role as well. Synchronize. It basically what the clock does is it keeps generating this kind of a regular pulse, just like our heartbeat, lub dub lub dub. So then why do we call this a clock? Because it facilitates us to synchronize. Synchronize. So this is first time unit, second time unit, third time unit, and so on. And also it's the initial pulse which we can change to say this is just 101010, but maybe what we need is 1001110. From this you can build this. But this timing is important. Timing. Because in sequential circuits, when time passes, we are interested what happened to this circuit component. At the end of first clock cycle, second clock cycle. Okay. So basically your processor speed is pretty much similar to the clock speed. Okay. So for example, I think my microprocessor is about 1 point some 4 gigahertz or something. So that means kilo is 10 to the power 3, mega is 10 to the power 6, giga is 10 to the power 9. Say, let's assume it's 2 gigahertz, that is 2 into 10 to the power 9. Pulse per second, pulses per second. So that is huge. That is 2 0 0 0 0 0 0 0 0 number of pulses per second. So this is 1 million. I think this is 2 billion. Okay. So there's a time aspect when it comes to some circuits. Okay. Right. So let's move on to latches. In order to understand latch, you don't need to understand much about the role of the clock, but you need to understand that what happens in the next time slots, and so on. You need to think through time to understand what the latch is doing. Okay. So basically, the word latch, the literal meaning is this is called a latch in English, like a simple lock. And computer engineers have borrowed this word to denote our digital electronic component called latch. So latch can be locked or unlocked. You can keep it locked, you can keep it unlocked. At any time, unlock one can be locked, lock one can be unlocked. So the latch in our digital electronic does similar thing. You can set it to one and let it keep it as one. At any time, you can reset to 0 and keep it as 0. It's like lock can keep it, unlock can keep it. Okay. So therefore, this is a building block for storage. 1 bit storage. So that bit you can set it to 1 or later you can reset it to 0. Okay. Or you can just let it the current value for another 10 clock cycles. So therefore, latch is the basic building block of a memory cell. Memory cell is capable of retaining 1 bit of data. Memory cell or registry cell. Okay. And again, you can create memory cell using different ways. One is using transistors or logic gates. So what we discuss here is creating a memory cell or registry cell using logic gates. So if you make it using logic gates, it's a latch or it's a flip-flop. But there's another way to build a memory unit, memory cell using capacitors. Okay, so that is another approach, but usually that is slower. But we are not going to discuss about how to create memory cells or registry cells using capacitors. We only discuss about how to build a memory cell or registry cell using latch or flip-flop. So flip-flop is a more advanced version of a latch. For some places, latches are good enough, but in some cases, we need a flip-flop. Right, we are going to look at three type of latches. What are those? SR latch, S bar R bar latch, D latch. Okay, SR latch, S bar R bar latch, D latch. We'll start with SR latch, set reset latch. It's very easy to understand if you pay attention. And if you have any confusion, not very clear, you need to then and there ask. So remember, what is the purpose of a latch? It's a memory cell. So memory cell, you can set it to 1 and let it retain as 1, or you can reset to 0 and let it retain as 0. Okay? And this is the basic circuit of a SR latch. You need two NOR gates. NOR gates. And two inputs. You can call it anything like A, B, O, P, Q, O, X, Y, but usually we call it R and S. R and S. By the way, SR stands for set reset latch because you can set it, reset it. Anyway, any latch is capable of doing that. But this is one of the first such circuits, so therefore they call it set reset latch, or simply we call it SR latch. It's a very simple circuit because you just need two NOR gates. Two NOR gates, two inputs, two outputs. So the two inputs are usually called R and S. The two outputs are called Q and Q dash, Q bar. And R is connected to the first NOR gate, S is connected to the other NOR gate. So then the output of the first NOR gate is an input to the second NOR gate. Output of the second NOR gate is an input to the first NOR gate. So that is what is meant by output is also fed as an input. That is why this is sequential circuit. That is why output depends not only on input, but the output of the previous cycle, clock cycle. Okay. And remember, your R is in the Q side. S is connected to Q dash or Q bar. Q bar. So why do we call it Q and Q dash? Because the expectation is when this is 1, this must be 0. When this is 0, this must be 1. That is what we expect. Right? So then someone will ask, why do we need two outputs? Actually, we need only one output. But As part of the designing, you need two outputs because this output is fed as the input to this. Therefore, what we need is only one output that we can set it and keep it remembered, or reset it and keep it remembered. But in order to build this, you need the second output also. Okay, because second output is sent as input to the first gate, no gate. At any time, if you feel like I have lost my understanding, so that is where you need to talk and get it clarified. Because otherwise, after some time, you will feel like you are completely lost now. And this is the truth table of SR latch. When S is 0 and R is 1, we call it reset. Reset means now Q is 0, Q dash is 1. Easy to remember, when R is 1, you reset. Reset means make your Q 0. But when Q is 0, Q bar is 1. How to make it reset? Give the R1 S0 combination input. And if you want to set it, just make your S1 R0. Then your Q will be 1, Q bar will be 0. And if you want to retain the value of memory, just make it both 0. If both 0, as long as both 0, whatever the last values will be remain. That is called memory. If you have set it and make it 0, 0, it's keep 1, 1, 1, 1. If you reset and then make both 0, it keep remaining as 0. So this circuit will do that. And we call this SR latch. So what are the operations? Reset the cell, set the cell, memory. If you reset and make it 0, 0, it will keep having this. If you set it and make it 0, 0, that means you set and remember. That means it will be keep this. Okay? So I do it very slow because I want to give you the chance to ask questions, get things clarified, right? I'm not at all hurry. So this is what I explained in the previous slide. So if you want to set, make it 1, make it 0, and that is 1 and 0. And if you want to reset, make R1 is 0. So then this will be 1, this will be 0. And if you want to retain the previous value, make both 0. So before making both 0, if you had this situation, it will retain as this in the next clock cycles. But before making it 0, 0, if you had set it to this or reset, then your current value is this is 1. This is 0, and that is why you make S0 R1. And after doing that, if you make both 0, then it will retain like this memory. That means it can set and memory or reset and memory. Set and memory means it remembers 1. Reset and memory means it remembers 0. But there's an invalid combination. You must not give both 1, 1 to the SR latch because it results in invalid output combination. So it doesn't corrupt your memory cell, but you then if you get into this S1 R1 situation, then again you need to reset this memory cell so that you can use it again. Right. So let's try to understand this. Not try to understand. You can perfectly understand this. But you need a bit of seriousness, serious thinking, logical thinking. Right. So let's see how can we set and remember. Set means you make S1 R0 and let it stay in that situation. That is S1 R0. Okay. Sorry, not S1 R0. Uh, Remember set means you make your output Q1. How to do that? You give S1 R0 and how to retain that? Once you do this, you make both 0. Still your previous value will retain forever until you change your SR values. Okay? Set and remember. So this is, now we are going to understand this. Is it really going to happen like that? So remember we want to set. How to set? S1 R0. Is that clear? We are going to give this latch S equal 1 R equals 0 input. And later we are going to make it both 0 to retain. But initially we want to make S1 R0. Now let's see what happens when S1 R0. What is going to be the output? In order to understand what happens when you give this combination, first you need to refresh what is the truth table of NOR gate, because these are two NOR gates. Right? What happens in a NOR gate? What happens in OR gate? When at least one is 1, it output is 0. When both are 0, only 0. Sorry. When at least one is 1, output is 1. When both are 0, only 0. But this is not an OR gate, this is an OR gate. So therefore in NOR gate, when both are 1, it is 0. It is 0. When one is 1, other one is 0, still it is 0 because O is 1, not O is 0. Because this is an OR gate. So then what about if both are 0? If both are 0, 0 0 O 0 is 0, then not 0 is 1. This is not the truth table of the circuit. This is the truth table of no gate. Truth table for this kind of a gate. But now we have two no gates. So let's try to understand how this works, but with the help of the truth table of the XOR gate. Sorry, truth table of the no gate. No gate. Right, so let's start. Now we have given this combination 1, 0. And according to the truth table, you can see that when at least one value is 1, output is 0. When at least one value is 1, we don't care whether both are 1, output is 0. And we already know that this is 1. When this is 1, regardless of this input, output is 0. When at least 1 or both 1, output is 0. Now already one value is 1 means there's no possibility of none is 0. That is the only place where you get 1. So that means always this is 0. Now therefore guaranteed this is 0. because one of the value is 1. But can we take that kind of a decision here? Remember, this is 0. We don't know what is this. So can we guess that? Because when this is 0, if the other one is 0, it is 1. Yes, we know that is 0. But when this is 0, if the other one is 1, this is 0. So therefore, by looking at this, you can't tell what is this because it's not good enough. You need to know what is this one also. But this is guaranteed 0. And remember, this 0 will be fed it here in the next clock cycle. Next time slot. And now we know that because this is always 0, in the next clock cycle it is 0, 0. And 0, 0 is 1. That means this is 1. And that means this bulb is lit. 1. At the same time, this 1 is now fed to this. Earlier, right? Anyway, this is always 1. So then 1, 1 is what? 0. That 0 is very clear. 0, no 0 is 1. That 1 is very clear. 1, 1 not is 0. 0 is very clear. Okay. 0, 0 is 0, not 0 is 1. Now it is stable. This is going to be 1. This is going to be 0, even when you don't provide any sub power. Okay. Because the power is indirectly provided by this one. Again, no power from here because it's 0. Power means constant voltage. Okay. Shall we check whether it's working like that? I'll go for logically. We used logically in previous sessions also. Try online. And you can see some of the latches and blah, blah, blah ready available also. Remember, this is a counter. But we will not use those. We will build it. I need 2 NOR gates. I need 2 inputs. And this output will be input to this output will be input to this. And we will take this output also. Let's connect it to bulbs. Okay. Let's take another bulb. So bulb is just to check whether the output is 1 or 0. And remember, this is R because I assume this is Q. So I assume this is Q. So this is R, this is S. And this is Q, this is Q dash, Q bar. Right, now what I want to do? Set it. What I want to do is set it. Right, how to set it? Make S1, R0. Can you see that it is set now? This is Q is 1. Q is 1, Q bar is 0. That must be the case. And now we have set it. Now can you explain it again? Using the truth table. So when this is 1, remember we have A, B, A, O, B, not, that is X, no gate, 1, 1, 0, 1, 0, 1, 0, 1, 1, 0, 0, 1. Because 0 plus 0 is 0, 0 bar is 1. Now this is 1. So when at least one input is 1, output is 1. So therefore this is 1. Right. So when this, sorry, uh, uh, 1, 1 is 0, 1, 0 is 1, 1, because 1 plus 0 is 1, 1 bar is, oh, I made a mistake, right? 1, sorry, I made a mistake in the truth table, right? Let me delete this, right, this way. So when both are 0, because 0 plus 0 is 0, 0 bar is 1. When both are 0, 1. No, when both are 0, right? Let me take it from the dot. Yeah, when both are 0, 1. Otherwise 0. Right? So I made a small mistake here. Otherwise 0. Why? 1 plus 0 is 1, 1 by 0. 0 plus 1 is 1, 1 by 0. Right? So therefore, when at least one value is 1, output is 0. Right? When at least one value is 1, output is 0. When both are 0, only 1. So therefore, now we know that at one value is 1. So let's get back to this one now. So this value is 1 means output is 0. Because when at least one value is 1, output is 0. And that 0 is very clear. And this is anyway 0. And 0, XO 0, no 0 is 1. Because 0 plus 0 is 0, not 0 is 1. And that one is very clear in the next clock cycle. And 1, 1 is 0. And that 0 is very clear. 0, 0 is 1. And that one is very clear in the next clock cycle. And again, 1 plus 1 is 1, 1 bar is 0. And it will keep remaining as this is 1, this is 0. Yes, you can see. So that is why this circuit is now 1 and 0. Okay. But what we do is we make it set and release both electricity. That means we set it and in the next clock cycle we can make both 0. Good news is even though you make both 0, this retain. Now look at what I'm going to do. Okay. Now I have set it. I am not going to keep it multiple clock cycles. Actually, in the next clock cycle, I am going to make it both 0. Right? Now, what is the current output? This is the current output. This is 1. This is 0. This is 0. This is 1. Okay. And again, I will draw the truth table. X no gate. A plus B bar. Okay. 0, 0, 1. 0, 1, 0. 1, 0, 0. 1, 1, 0. Right. Right. So now what I do is, now this you can understand, right? Because when this is 1, when at least one is 1, output is 0. And that 0 is very clear. When both are 0, output is 1. And therefore like this. But in the next clock cycle, what we do is, now look at very closely. Once you do this, we don't keep that for the next clock cycle, in one clock cycle, we do that. Now this is the output. Now we make both 0. That is memory. And you can see that even when I make both 0, this has not changed. This has not changed. Still this is 1, this is 0. Now you need to explain why is that. I just make it both 0, but still this is lighting. Understand. Now remember, by the time you make both 0, it was in this state. And all of a sudden you make this 0. That means all of a sudden you make this 0. But by the time earlier clock cycle, this was 1, therefore this is 1. Earlier clock cycle, this is 0, therefore this is 0. Now all of a sudden you make this 0. Now this combination is 1, 0. 1, 0 combination means output is 0. Remember, 1, 0 combination is output is 0, again 0. And that 0 is very clear. Now we have both 0. Both 0 means 1. And that one is very clear in the third clock cycle. And again 1, 0 is 0. And that 0 is very clear. Both 0 means 1. So therefore, now even though you make both 0, it remember that this is 1, this is 0. This is Q, this is Q dash. It's not magic, pure logic. Okay. That is how you set and remain memory. Set and memory. Okay. So first because this is your R, remember Q side is R. This is yours S. So first you made this reset. Sorry, first you make it set like this. Then you release it. Still it is the same. Okay. Any questions? Now let's see how to reset and take it to the memory. This is how you do it. How do we reset? You take R1 S0. Now S is 0. Now you make it R1. Reset means this is 1, this is 0 because Q dash is 1. Okay, let's reset. Yes. Now we reset. But in the immediately next clock cycle, we are going to make it both 0. Memory. Now I can see still it retained. That anytime I can reset and retain. Anytime I can set and retain. So this is I'm going to set and memory. I'm going to reset and memory. Reset memory. You can see it's a memory. Now that is why we call this a memory cell. Or we can use it as a memory cell. That means at any time we can set and make it memory. Ask it to remember that value. At any time we can reset and ask it to make it as a memory. Or remember the value. Okay, right. First I explain how to set it. Now I will explain how to reset. So reset means what? You make R1 is 0. Now what happens? This is 1. Okay. This is 0. And when at least one value is 1, output is 0 because we don't know what are these. So when at least one is 1, it is 0. Therefore, this is 0. And this 0 is very clear. 0, 0 means 1. And output is like this. Of course, if you keep this, again, this will be 1. 1 plus 1 by 0. That 0 is very clear. 0 plus 0 is 0. 0 by is 1. It keeps. But you don't need to do that. You just need to do it only once for one clock cycle. And then you can release it. How to release? Make it 0. You can see still it retain. Now you need to understand when you make it 0, what happens? Now in the previous clock cycle, this was 1. So therefore it was 1. In previous clock cycle, this is 0. Now you make it 0. So therefore now this is no longer 1, this is 0. Because you make it memory. And according to the truth table, when at least one value is 1, output is 0. Therefore this is 0. And that 0 is very clear. When both are 0, output is 1. That 1 is very clear. And 0, 1 is 0. That 0 is very clear. Both 0 means 1. Now you can see it retained. Right? It has retained. So we managed to reset and retain. How do you know with this reset? Q bar is 1, Q is 0. So that means at any time we can set and retain, we can reset and retain. I will again show it. I will set and retain. By the way, this is my R. Let me have some labels. Make it clear. So this is my S. And this is my R. This is my Q. And this is my Q dash or Q bar. Right. Again, I will demonstrate. I want to set. Make it 1. Make it 0. Sorry. This is not S. This is R. I made a mess of that, right? So this is my R. Remember, R is above. And this is my S. Okay. Right. Now I want to set it. How to set it? Make it 1. You can set. And how to remember? Make it back 0. It's still remember. How to reset? Make R1 S 0. Reset. How to remember? Just make it both 0. So that is how SR latch works. We can set it and let it remember. We can reset and let it remember. So it remember the previous value until you set or reset again. Okay. So then there is another special thing about SR latch. That is, don't make both 1. Remember, both 1 is invalid. Right? Invalid. So therefore, what happens if you make both 1? Both 1. This is 1. This is 1. And now you can see that both are 0. It can't be the case. You can't have a situation where Q is 0, Q dash is 0. Both are 0. Right? If Q is true, 0, Q dash must be 1. If Q is 1, Q dash must be 0. Therefore, this is not a logical thing to happen. The reason is when at least 1 is 1, output is 0, right? Here, right? Output is 0. And here also when at least one input is 1, output is 0 because this is 1. That 0 is fairy tale, that 0 is fairy tale. And that continues. So therefore, make sure you don't give 1-1 scenario for SR latch. 1-1 scenario results in wrong answers, wrong output, unreliable output. So that is why we say S equal 1, R equal 1 is invalid combination. Don't do it. If you do it, you need to again reset the latch. And that's it about SR latch. Any questions? So this is reset and remember, okay? And this is the invalid scenario. If you go for 1-1, both become 0 because when at least one input is 1, output is 0. Now this is also 0, this is also 0. Okay? Right. So this is a A-level ICT question. A-level ICT question, right? Not a BIT question. Because BIT questions are super difficult. Okay? But you get only 1 or 2 questions from latches. not more than that. Right. So this is anyway textbook question. Okay. Right. What is the answer? This 2023 A-level MCQ question. A-level ICT. Consider the flip-flops. Actually, though we call it flip-flop, this is actually a latch. So you can just consider it as latch. Okay. It's not wrong to say flip-flop, but flip-flop is slightly different device. It's advanced version of this, but we sometimes call everything as flip-flops. Anyway, don't worry. Consider the following flip-flop or the latch circuit. Assume that the S input is 1 and the R input is 0. What will be the output at Q? Actually, this is not MCQ paper. This is structured essay. Okay. Right. What is the output of Q? S input as 1. R input as 0. That means you set it. Now Q is what? Q is what? Simple as that. Okay. Q is what? Second part. What will be the output at Q if the S input is now made 0? Then only 0 or not. Then S is now 1, 0. Now this continues 0. Now what is the output of Q? Remember, this is memory. 0, 0 is memory. So therefore, by the time you make memory, whatever the previous output will result will be the retained. And previously it was Q1, Q dash 0. When you make both 0, it will retain like that. Again, if you make both 0 for the third clock cycle, it will retain like that. Third part, what will be the output at Q when R input is now made 1? Now you make R1 is 0. That means reset. So when you reset, this is 1, this is, sorry, when you reset, this is 1, this is 0. That is what is by reset. Reset means Q dash is now 1. So therefore answer is, what will be the output at Q? Now the output at Q will be 0. So the answers are 1, okay, 1 and 0. 1, 1 and 0. Because this is set it, remember it, and reset it. Right? That's it. 1, 1 and 0. Right. So our next subtopic is gated SR latch, which is a bit of an improvement to the SR latch. So this is an improved version of SR latch. Right? This is an improved version of SR latch. And you can clearly see this is SR latch. Where this is R, this is S. But we have now introduced two AND gates. Two AND gates and another input called enable. So that means now we have three inputs. Still this is your R. This is your S. So S side is S. R side is R. Remember R side is Q side. Reset is Q side. Okay. Now the only difference is still when your R is 1, S is 0 and enable is 1, because remember if enable is 1, R dot 1 is R. Look at it like this, okay? When enable is 1, R dot 1 is R. Remember A dot 1 is A. One of the rule. So when this is 1, 1 dot 1 is 1. When this is 0, 0 dot 1 is 0. Whatever this value is, this value. So therefore A dot 1 is A. So therefore when enable is 1, when R, this is actually R, this is S. Because S dot 1 is S. R dot 1 is R. So therefore when enable is 1, this gate is same as SR latch. When enable is 1, right? Look at this. When enable is 1, S1 R0 is set. R1 S0 is reset. 0 0 is memory. 1 1 is invalid. So this is previous circuit. Or result is same as previous circuit. Then what happens if E is 0? When E is 0, regardless of S and R value, 0 dot something is 0. Because in AND gate, when one value is 0, the output is 0. Here also, when the enable is 0, this is 0. So enable is 0 means giving 0 0. Giving 0 0 means it doesn't matter what happened to S and R. When enable is 0, this is memory. This is memory. Okay? When enable is 0, X means any value. We don't care. Whatever the previous value will be retained. Okay? So therefore now we have another way of memory. If you want to make it memory, just make enable 0. Then we don't care what happened to SNR. Whatever the value you had at the time of enable 0 will be retained. Because this is keep getting zeros. Keep getting zeros. So the advantage of this SR gated SR latch is we have, if you want to make it memory, either you make enable 1 and SNR 0. Or there's another way, that is just make enable 0. Earlier enable 1 and SNR 0. Or forget about SNR, just make enable 0. Whatever the current value will be retained. But if you want to set or reset, first change enable to 1 and then do the correct thing. That is set means S1 R0, reset means R1 S0. Is it clear? Is it clear? Right. So shall we add these two gates into our circuit diagram? I just need two AND gates. Two more AND gates, okay? Two more AND gates and one more input. AND gates. And this is connected to here. 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 Let's label this also, okay? Anyway, we have already we have the label. We don't need to worry. But now we have one more input, that is enable. This is my enable, okay? Let me have a label for that. I'm doing this very slowly because this is one of the hardest topic to understand. Right, so enable is connected to both this one and this one. Now my enable is 0. Sorry, my enable is 1. So when enable is 1, this just act like normal SR latch. Right? Normal SR latch. Okay. So let's make it reset. R1 S0. Reset. Reset. Let's make it memory. Memory. Let's make it set. S1 R0. Let's make it memory. Okay. Let's make it again set. Yes, already set. Let's make it memory. Let's make it reset. Let's make it memory. It's like a normal SR latch. That is normal because you can see that here R1 and 1. R dot 1 is R. S dot 1 is S. So therefore this is same as SR latch. But now what is the advantage of having enable? Say now I have, let's set it again. Set means S1 R0. Now earlier to make it memory, we make it 0. But this time what we are going to do is, make it memory, I can make enable 0. Now, it doesn't matter what you are doing here, right? It doesn't matter whatever the changes you are doing here, when as long as enable is 0, it is memory. You can see this doesn't change. This doesn't change. I will again enable now. Now I will reset. Reset. Now if I make enable 0, now it is again memory. Then whatever the changes we are doing here doesn't matter. It doesn't matter, right? Because now this is memory. So therefore we have a better way of making a memory now. Just make your enable 0. As long as your enable is 0, it doesn't matter what happened to these inputs, it's remembering things. But again, if you want to do some changes, make enable 1 and do the change. Say I want to set it. Yes, if you want, you can make it memory like this, but the better way is just make it this so that even when there's a changes, it doesn't affect. Is it clear? Is it clear? So then if you are a critical thinker, you might ask, now we have already a way to make it memory, right? Make both 0. When both are 0, this is memory. So then why do you need another way of making memory? Okay. Why do you need another way of making memory? Because now we have two ways of making memory. That is enable 1 and make those 0. Or else simply make enable 0. Then it doesn't matter whether this is 0, 0, 1, 0, 1, 1. Its previous value is preserved. Can you tell me, right? Can someone tell me what is the use of then when we already have a both 0 scenario? Why do you need another way of making memory? Another way of making memory. So the answer is yes. I already got the answer in the chat. Right? Make it more reliable because this is a circuit. Remember, in computers there are, even if you take microprocessor, there are billions of transistors, millions of logic gates. Logic gates. If you take memory, millions of logic cells. Sorry, memory cells. So therefore, in your computer, there's a possibility of stray signals. Stray කියන්නේ අයාලේ යන දඩාවත යන. එකපාරට මේක වන්න වෙන්න පුළුවන්. Because these are output from other gates. Because this is your main inputs. But now, if you want, when you want to make a memory, so just make this 0. So then even though you get any stray signals, memory is memory. Right? Memory is memory. So that is better. Now we have more reliable way of keeping our values remembered. Right? Right. So remember now this is 0. Now this doesn't change even though whatever happened to SNR. Even though you get some pulses, stray pulses, it doesn't matter. Memory is memory. Right? So again, if you want to change it. Say now I want to reset. Now again do it. Then it doesn't matter what happened to these pulses. Even when both are 1. Remember earlier 1, 1 is invalid scenario. Now even that invalid scenario is okay. Why? Enable is 0. This is memory. Even now remember in normal SR lag, both one is invalid scenario. But now it doesn't matter because enable is 0. But if you make both enable one, that is a different story because now it is invalid. But as long as your enable is 0, one is also not invalid. Now you can see because I take it from invalid to the 1. Okay. Now I need to, now you can see that is why we say don't make it 1, right? Now again I need to refresh and get it. Right. So that is how you make a gated SR latch. Gated SR latch. So there's a possibility of stray pulses. So stray dog can balance. And gated SR latch provide a third independent input called enable to retain current value memory, which is immune to stray pulses. Immune කියන්නේ ප්‍රතිශක්තිකරණයක් තියෙනවා stray pulses වල. Okay. Is it clear? Now, by now you must be comfortable with SR latch, gated SR latch. Okay. ඔයගොල්ලෝ digital electronic කරනවා නම් මේවා තමයි දින topics. Digital electronic කරනකොට. computer ඇතුලේ latches use කරනවා. memory cells නැත්නම් register cells විදියට. Right, so I already explained this, okay, gated SR latch. Demo also we did. Right, so this is an exercise. Remember මේ ගේම ගහන්නේ අන්තිමට මොකෙන්ද? confidence කියන එකෙන් මතක තියාගෙන ඉන්න නෙමෙයි. ඔයාලට confidence නම් එකෙක්ටවත් බය නැහැ. ඉන්ටර්විව් යන්න බයත් නැහැ. ජොබ් එකට යන්න බයත් නැහැ. ලෝකේ ඕන තැනක යන්න බයත් නැහැ. තනියෙන් රංචු වෙන්න වෙන්නේ රංචු වෙන එක මොකද? තනියෙන් එන්න බය වුන් ටික. රංචු ගහලා එන්න. right, ටගල මේක කරා. draw the output signal. දැන් මේ සැරින් සිග්නල් වෙනස් වෙනවා. S එක වෙනස් වෙනවා. R වෙනස් වෙනවා. ඔයා මේක අඳින්න ඕන අර ECG එකක් වගේ මේ Q සිග්නල් එක අඳින්නයි දිනනවාට. This is the circuit. ටගල කරා. You need to draw the entire signal, right? So this is just one moment in time, but you need to draw the entire signal. වයි ගන්න මේ වෙලාවේ මොකද්ද මේ වෙලාවේ මොකද්ද මේ වෙලාවේ මොකද්ද එහෙම කියලා හිතේ දාන්න. And enable is, you can see in this example, enable is always 1. But S and R keep changing time to time. If you are logging to the session using laptop code, something like that, tab, you can draw it in the screen itself. Screen එකේ මදි. But your screen, right? ඔයාගේ screen එකේ අදින්න මගේ common screen එකේ අදින්න එපා. You can take the annotation and draw it. But make sure you draw it in your screen. නැත්නම් මේ tool එකක් තියෙනවා නම් pen tool එක right? So this is epic pen. ඔයාට අදින්න පුළුවන්. එතකොට ඔයාගේ අදිනේ අපිට අනිත් පැයට පේන්නේ නැහැ. හරි? ශ්‍රීනේෂයා කරලා දිමන්නේ. Right. So let's draw it. Enable is one means this is normal SR. This act like a normal SR latch. So therefore we can forget about this. This is normal SR latch because enable is one. So initially both S and R is zero. Therefore we don't know what happens because we don't have the idea about the previous thing. We can draw from this point. Of course, let's say it's earlier also one. Let's assume earlier also one. Or we don't know whether earlier is zero, but this part we can't exactly tell. Okay, let's take for the time being earlier. Let's assume initially it's one. Okay, because this also say Q is one. Right, so let's say Q is one. So then S1 R0, that means set. S1 R0 means set. So therefore this part it is one. Now both zero means memory up to this point. Both memory means this value is retained. This value is retained. Now S1. S1 means again set. So that means it doesn't do any difference. Still it is 1. Now again both 0. Both 0 means memory. That means still it is 1. So up to this point it is 1. And now you have R1 is 0. That means reset. So then you go into the memory. It retains until this point. Because 0 means memory. Memory means 0 is remembered. Now again we go into this S1 R0 that is set. Right? S1 R0 means you again set it. And then again memory until this point. Memory means this value is retained. Now again you go into R1 S0 that is reset. And up to this point memory. And again reset. So that means it doesn't change because anyway it's 0. And again memory. So this is the output. It goes like this. And goes like this. And goes like this. So this enable is not going to do anything because enable is always 1. So that is output. මේක යටින් ඇදලා තියෙන හරි මුල අවස්ථාවේ බිඳුවයි කරලා තියෙන. ඒක මම කියන්නේ මේකට අපිට වගේ කියන්න බෑනේ. That is fine. අපි යන්නේ මෙන්න මෙතන ඉඳන් හරියට යන්නේ හරි. Right. So let's do another exercise. Now draw the output, but now this time enable is also changing. Now draw the output. මේවා නෙමෙයි දෙන්නේ ආ ඊට පට්ට අමාරුයි දෙන්නේ එක්සෑම් එකේ හරි. question එකක් හරි දෙකක් හරි තමයි දෙන්නේ ගොඩක් අයට ඊට වැඩි දෙන්නේ නැහැ. බොහෝ විට එකයි දෙන්නේ latch flip flop වල question. ඒක නොකරත් ඔයාලට ඒකට යන්න පුළුවන්. නමුත් වැඩි දෙයක් ඉගෙන ගමු. ඒතකොට අර බය නැහැ. මොකද ඔයා හිතන්නේ නිකමට හිතනවා ඒක කරන්නේ software engineer කෙනෙක් කියලා. හරි. මොකද අපි ජොබ් කරපුවාන්දනේ. සමහරවිට ඔයාගේ වම් පැත්තේ ඉන්න පුළුවන්. කොළඹ කැම්පස් එකේ UCSC එකේ ඉන්ටර්නල් ඩිග්‍රී අරගෙන software engineering කරන්න ආපු එකෙක්. දකුණු පැත්තේ ඉන්න පුළුවන් ස්විත් එකෙන් ආපු එකෙක්. ඉස්සරහ කියුබිකල් එකේ ඉන්න පුළුවන් මොරටුව කැම්පස් එකේ ඉලෙක්ට්‍රිකල් ඉංජිනේරින් කරලා IT එක දැන් software development කරන කෙනෙක්. ඒත් ඒගොල්ලොත් එක වඩේකට ඉන්න පුළුවන් නේද? පොඩ්ඩක් ඉලෙක්ට්‍රොනික කරන්න නම් දැනගෙන ඉන්නවා. නැත්නම් බය හිතන ඒගොල්ලොත් එක වැඩ කරන්න එක ප්‍රොජෙක්ට් එක. Remember, enable is 0 means memory. It doesn't respond to the stray pulses. It doesn't respond to SNR variations when enable is 0. Now, enable is 0. So therefore, whatever the initial value will be retained. Again, I don't know what is the initial value, right? Let's assume initial value is 0 because in the previous example, initial value was taken as 0. So therefore, let's assume initial value is 0, right? Okay, because enabled is 0. So that means memory. So let's assume initial value is 0, okay? Up to this point. If initial value is 1, it will be like this, right? I assume that initial value is 0 because the question doesn't say it. And now enable is 1. Now it is 0, 0 means it's memory. So therefore, whatever the initial value will be retained. 1 kila gattana medan 1 na because it's memory. 0, 0. S 0 R 0. And now we have S1. S1 R 0. Enable is enable. Now it's a normal latch. That means 1. That means 1. Right? Because enable is 1. Then it is again memory. 0, 0. Up to this point, it is memory. Because it's enable. Now R1 S0, that is reset. Reset. Up to this point, and then again memory. Then again memory up to this point. Now enable is 0. Enable is 0 means memory. Then up to this point, it is not going to respond to any of these. Because now enable is 0 means memory. These are now stray signals, stray pulses. Now it's again enable, but it continues like this because it's both 0. Now we have S1 R0 that is set because it happens when enable. And still it's enable, but memory now. Now enable is 0 means that is memory. Therefore, it will be whatever the value will be retained. This is the output. I assume that initial 0, right? Yes, that is the output. Any questions? Anything not clear? I told you this is you need to think in the next level of seriousness, like engineer, electronic engineer, digital electronic engineer. Right. So let's see last year what kind of a question they have given. Now you can start looking at the past papers, right? Some syllabus we are almost done. 2024. One question එකක් තියෙනවද කියලා? 23. කානෝ මැප් we have already done, right? මේවා දැන් කරන්න පුළුවන් ආ. මේ මේ ඉතින් මේ අය ඔයගොල්ලෝ කරනේව නෙමෙයි ආ තාම මේවට ආවේ නැහැ. මේවා ආවිල මේවා කරද්දි ඉතින් ඔළුවෙන් හිටගෙන කල්පනා කරන්න ඕනේ ඊට පස්සේ ආ. එහෙම තමයි engineersලා. So this is not a latch, this is a flip flop. That is why you have the clock signal. Right? මේක දෙන්නේ කරන්න බැරි වෙන්නව තමයි දෙන්නේ. හරි? මේක මේ ලකුණු ඕන නම් මේ ලකුණු ඕන නම් ඔයා ඉලෙක්ට්‍රොනික ඉංජිනේර කෙනෙක් වගේ හිතන්න ඕන. හැබැයි ඕන නම් මේ ලකුණු නොගෙන ඉන්න පුළුවන්. මොකද මේ වෙන ක්වෙස්චන් තියෙනවනේ කරා. මේ වෙන ක්වෙස්චන්ස් තියෙනවා. That is 2023. So this is not a latch. These are not latch. There's no latch question in that way. Like no latch question. Or they can lazy paper. Right? 2021. This is another one. Clock signal at the other. Yeah. The question at the other. One question only. ගොඩක් අය එකයි දෙන්නේ ඉතින් හරි ඒක ගන්න පුළුවන් නම් ගන්න. ගේම් එකක් දීලා ගන්න පුළුවන් නම්. හරි. 100ක් ගන්න පුළුවන් නම් 100ක්ම ගන්න. So I think I showed you some of the because batch 4 I explained you uh, about the importance of getting good results, right? Because 2 days ago they released semester 2 results. This year there are 2 students who got you have 10 subjects. 10 subjects in level 1, semester 1 and 2, semester 1 5, semester 2 5. There are 2 students who got 9 A's and B. 9A, 1B. Both of the students දසමින් මිස්සලා දෙනවා ඒ 10ක් ගන්න එක. යුනිවර්සිටි ලෙවල් එකේ ඒ 10ක් ගන්න බෑ ලේසියෙන් හරි. යුනිවර්සිටි ලෙවල් එකේ. ඒක ඩ්‍රීම් එකක්. ඒ 10ක් ගන්නවා කියන්නේ. කියන්නේ ඔක්කොම සබ්ජෙක්ට් වලට ඒ ගන්නවා කියන්නේ හරි. So where is that? You see? A minus A minus B. එකම B එකයි තියෙන්නේ. Fundamentals of Maths. ඔයගොල්ලෝ semester 1 තියෙන math subject එකේ B එක අරන් තියෙන්නේ. හරි ඔයගොල්ලෝ ගොඩක් අර ගණන් ගන්න නැති subject එක. අනිත ඔක්කොම A. හරි? So there is one student. There's another student. You can see A plus උත් තියෙනවා. හරි? B plus. A fundamentals of maths වලට B plus එක දින් බලන්න. හරි. නැත්නම් යාරත් A 10ක් නේ. A 10ක් කියන්නේ first class එකට යන්න පුළුවන්. first class එකට ගියා කියන්නේ scholarship එක වෙන ගොඩක් කරා. first class ගත්ත කියන්නේ. PhD එක කරන්න පුළුවන්. Right. So it doesn't mean that everyone got like that, right? Some students get a lot of A's and B's. C pluses, some students have a bit of repeat subject, right? එහෙම තමයි ඉතින්. ඔක්කොම එක වගේ නෑ. මම කියන්නේ කරන්න බැරි දෙයක් නෙමෙයි මේක හරි. කරන්න බැරි දෙයක් නෙමෙයි. ඔයගොල්ලෝ ලබන පාර try කරනවා මේ 10ක් ගන්න. අර fundamentals of math subject එක පැයයින් paper එක පැයයින් සමහරවිට upset වෙනවා. රිකා වෙන්න වෙලාවක් නෑ. පැය paper එකක් දෙනවා. හරි නැත්නම් ඒකත් ඒ තමයි. හැබැයි මේ වගේ එක ලකුණක්වත් අතාරින්න එපා. නේද? මම මේ question එක අතහැරලා යනවා ඒව බෑ. මේ question එක අතහැරලා යනවා අර question එක අතහැරලා යනවා කියලා ඒ විභාග වලට යන්නේ නැහැ. ඔක්කොම කරන්න බලන්න තමයි යන්නේ. හරි? Right, now we move on to D-latch. So now we have finished SR latch, gated SR latch. So D-latch is very easy to understand because it's a special case of SR latch. Data latch. Right, data latch. Again, you can see that this is your SR latch. This is your SR latch. 2 NOR gates. Okay. 2 NOR gates. So then what is the only difference? Usually SR latch has having 2 inputs. This input, but this time you have only 1 input. And that input is directly connected as your S input. It is going through NOT gate and connected as your R input. So therefore now all of a sudden your 2 input is 1 input. Other than that, this is not your normal SR latch. And when you build this kind of a circuit, we call it D-latch or data latch. Data latch. So there are some advantages of D-latch and disadvantages. What are those? Because now we have on 2 states, D0 D1 because there's only one input. If you have only one input, there are two possibilities. That input is 1, that input is 0. So therefore, all of a sudden, my truth table is very simple now. Right? So then what happens when D is 1? Okay, so let's say D is 0. D 0 means S0 R1 because not 0 is 1. So that is reset. Reset. So therefore, when D is 0, it is reset. Reset this memory cell to 0. Then what happens when you make D1? When D1, now this is 1, not 1 is 0. That means you set it. So therefore, now we have only two states. Reset, set. There's nothing called memory. When you reset, until you make it set, it is memory. When you reset, as long as you don't do any changes, it is reset. So memory means just stay in the same thing. Until you change it, it is memory. Therefore, this is super simple now. There's no invalid state. You don't need to do any change to make it memory because you just do it and සද්ද නැතුව ඉන්න එක. ඒක කළා සද්ද නැතුව ඉන්න. ඒ කියන්නේ සද්ද නැතුව ඉන්නවා කියන්නේ ඒක තමයි වැඩි. Right. So we have only one input and obviously you only have the two outputs. Okay. So therefore we can look at it in another way, that is output follows input. When input is 1, this is 1. When input is 0, now this is 0. Right? මෙයා තමයි අපේ ප්‍රධාන output එක. When again this is 0, still it is 0. Say this is 1, this is 1. So therefore output follows input. Right? That is called D-latch. Right? D-latch. D-latch. When this is 1, output is 1. When this is 0, output is 0. Output means Q. Of course, when Q is 0, Q dash must be 1. Is it clear? Do you need a demo? නේද? ඔයාලට තනියෙන් කරගන්න පුළුවන් හරි. ඔයාලට logically එකට ගිහලා මේ drag and drop කරලා හදාගන්න. මෙන්න මෙයා තාම දගලනවා. දැන් තියෙන එක input එකයි. That is D. And now we need a NOT gate. Going through NOT. And other one is going like that. That's it. This is your D. Now D is 0. Yes, Q is 0. D is 0 means Q is 0. Right? D is 0 means reset. Q dash is 1, Q is 0. D is 1 means set. Set. දැන් මේක ආයෙ reset කරනවා කොහොමද? Now reset. So when this is 0, this is 0. When this is 1, this is 1. That is what we say output follows input. Input එක තමයි output එක වෙන්නේ. When this is 1, this is 1. When this is 0, it is 0. Memory කියන්නේ ඉතින් ඒක වෙනස් නොකරන තාක්කල් එයා තමයි memory. Okay. So that is called D latch or data latch. Okay. So the basic D latch can be set to 1 and reset to 0, but we cannot make it retain the value memory. Memory එකක් නෙමෙයි අතර මෙතන තියෙන්නේ කියවු එක තියාගෙන ඉන්න එක විතරයි කරන්නේ. ඒකන්ට ටිකක් ඔයාලට සමහරට හිතෙන්න පුළුවන් මෙතන memory එකක් නැද්ද කියලා. ඕන නම් memory එකක් හදන්නත් පුළුවන්. මේක අතර memory තමයි යා. කියවු එකේ එම්මම මතක තියාගෙන ඉන්නවා. හැබැයි ඒක memoryම නෙමෙයි. right? ඒ කියන්නේ අර මෙතන වැරදිලා 1 මොකද වෙන්නේ? අර අපි කියන්නේ මේක අර safe memory එකක් නෙමෙයි, reliable memory එකක් නෙමෙයි, because if there's a stray pulse that all of a sudden make it zero, now it is that stray pulse this is going to respond to the stray pulse. stray pulse එක එන්නේ මෙයාම තමයි. ඒ කියන්නේ අපි බලාපොරොත්තු වෙන්නේ නැති වෙලාවක එකපාරට 1 එකක් එනවා. එතකොට මෙයාත් වෙනස් වෙලා යනවා එකපාරට. So what is the solution? Use of enable. Use of enable. So when you have enable, so then you have another way of memory. So during that time, when we get stray pulses here, it doesn't change your output. Because when enable is 0, it is memory. It doesn't respond to D. When enable is 1 only, your D latch is behaving like a D latch. Is it clear? ඔන්න enable එක උදාම ටක් කරා. So let's have another toggle switch. And this is my enable. Okay. Ready. Maintain. Connect again. තව end එකක් දාලා පෙදා. ඒක කරෙක්ුනේ නැත්තේ. තව end එකක් දාලා පෙදා. So you need two AND gates, right? But ඒක අමතක වුණා. I need another AND gate. And then I have the enable. Okay, right now enable is enable, right? Now when D is 1, Q is 1, because enable is enable. When D is 0, Q is 0. Okay, no. Okay. So that means what? Q follows D. Q follows D. Right? When enable is 1. Right? When enable is 1, now again I make it D1, Q1. Q1 means Q dash 0. Again, if I make it 0, Q0, that means Q dash, that means it's a normal D latch now. But if you want to make it lock now, immune to stray pulses, you make enable 0. Now it doesn't respond to changes in D. Right? Even though you get a stray pulse, your memory cell is still remembering the old value. The value that you had it at the time of you make disable. Okay. And again, if I make it enable, now it's going to respond to my D. This is gated D latch. Now you know SR latch, gated SR latch, D latch, gated D latch. So D latch is a special case of SR latch. So again, the advantage of no invalid scenario. මතකද අර කලින් එදි ගැහි ගැහි හිටිය අර invalid scenario එකට ගිහිල්ලා. මේක invalid scenario එකට යන්න බෑ. enable කරත් disable කරත් invalid scenarios නම් යන්නෙම නැත. Because there's no possibility of one mark in D latch. Okay. Right. Do this as exercise. මේ වැඩේ තේරුණා නම් මේ ගහන ගේම ගහන confidence එකෙන් හරි. මේක exam එකට ආවත් නැතත් ඔයා මේ ගන්න confidence එක තමයි ඔය ඉස්සරහට ආවා යන්නේ. interview යන්නේ. ලෝකෙ වටේ යන්නේ. ඕන කම්පැනි එක වැඩට යන්නේ. නැත්තම් කස්ටියත් එකතු කරන් යන්න වෙනවා කොහෙටද? පැලවත්තේ කාර්යාලය ඉස්සරහා ගිහලා කියන්නේ නෝ උඹලට නම් පාර්ලිමේන්තු ගියා අපි මහා පාරේ කියලා. ලැජ්ජ නැතුව. Do this. Okay, right. So now Initially, enable is enable. That means it act like a normal D latch. So D0 means Q is 0. So remember Q follows D. එහෙම මතක තියාගත්තම හරි ලේසි. Q කියන එක නා D ම තමයි. Enable වෙලා තියෙන ලාරි. So then D1 means Q follows D. Still enable, right? මෙතනට නිකන් මේකම තමයි output එක. හරි? Up to this point. Now enable is 0. That means memory. නෑ ඉතියා rest රඟ මේවා කරන්නේ නැහැ. මේවා stray currents there. So it remains the what current value memory because enable is 0. Now again enable is enable, but anyway still Q is D0 means now Q is 0 enable. That means Q follows D. Q follows D, right? Because enable is enable. And again Q follows D. Q follows D. And still enable Q follows D. Now memory. Because it's enable is disabled. Now again enable Q follows D. Enable is enable. And Q follows D. When Q becomes 0, D becomes 0. Sorry, when D becomes 0, Q becomes 0. So this is the output. That is the output. Okay. Right. So our next latch is S-R latch. It's not nothing new. Only thing is we can build the same thing using earlier we used no gates. If you want, you can do the same thing using NAND gates. So then you call it S bar latch. Why do we call it S bar latch? Just to give it a different name. Because we use different gates. Other than that, it is same thing. නිකන් නමක් දෙන්න ඕන නම් වෙන නමක් දීලා තියෙනවා S bar කියන. මේකට SR latch කියන්න බෑනේ කලින් එකේ තිබුණ no gates එකනේ. Okay. So this is again Q and Q dash. Earlier we call it R and S. මතක නේද? R තියුනේ Q ඉන්නත පැත්තේ. But rather than R, now you call it S bar. Rather than S, we call it R bar. යෝග නැත්නම් RS SR ම තමයි. SR ම තමයි. But rather than R, we call it S bar because anyway S bar is R. Rather than S, you call it R bar. Okay. So remember earlier when R is 0, S is 1, it is set. Now remember R is S bar. Right? S is R bar. Earlier when S is 1, R is 0 set. Yes. Right? S is 1, R is 0 set. So in this case, R bar 1, S bar 0 is set. Earlier, when R is 1, S is 0, reset. Yes, this time it is S bar and R bar. Earlier, when R and S both 0, memory. But this time there's a difference. This time, when both are 1 memory. S and R, nothing, S bar, R bar. Right? So that is the only difference. Earlier, when both 0, memory. But this time, both 1 is memory. Earlier, both 1 invalid. This time, both 0 invalid. මොකද ඉන්නේ NAND gate එකක් හඳයි ඒකුනේ. Because now what we have is NAND gates. So you can compare the SR latch and S bar latch. Because S bar is your R bar is your S. Earlier 0 0 is memory, now invalid scenario. Earlier 1 1 is invalid, now 1 1 is memory. Because we have NAND gates. So this is a comparison. SR latch, S bar latch. So earlier 0 0 is memory, now 0 0, sorry, earlier 0 0 is memory, now 1 1 is memory. Earlier 1 1 is invalid, this time 0 0 is invalid. But other things are the same. 1 0 1 0 set, 0 1 0 1 set. මුදරම දෙන R bar කියන්නේ S ට, S bar කියන්නේ R. ඉතින් මේකට දිවා කරලා බලන්න ඕන නම් බලන්න. ඉතින් අර NAND gate එකේ truth table එක දිහා බලන්න කල්පනා කරන්න. truth table එක දිහා බලන්න කල්පනා කරනවා අර වගේම memory එන විදිය ඔයාලට දැන් පේනවා. දැන් මේක කරන්න එකක් කරාට පස්සේ 10ක් කරන්න ඕනේ නැහැ. So here now you'll concentrate on NAND gate and think about next clock cycle what happens. This time when at least one value is 0, output is 1. Right? Again, at least one value is 0, output 1 can what? That means 0. Because this is an AND gate. Then output is 1. Now, when one value is 1, we can't say because when this is 1, this is 0, 1. When this is 1, this is 1, 0. ඒකකට ඊළඟ clock cycle එක වෙන කල්පනා ඉන්න වෙනවා. Next clock cycle, this is 1. Now we know that 1, 1 is 0. ඔන්න දැක්කද 0. මෙයා 0, මෙයා 1. Then this 0 is fed it here. 0, 0 is 1. And that one is fed it here. 1, 1 is 0. That 0 is fed it here. Then no මතක තියන්න. ඊපස්සේ memory කරා මොකද වෙන්නේ? දෙකම memory ගන්න කොහොමද? දෙකම 1 කරලා. 1 කරන්න කලින් දීච්ච value දෙක ඔළුවේ තියෙනවා. It's up to you to do that. Okay? Up to you to do that. මේක තමයි reference table එක. Truth table of the NAND gate. This is not the truth table of S bar latch. This is the truth table of NAND gate. Right? Just make sure this is truth table of NAND gate, right? ඒක බලන්න අපි කල්පනා කරලා. කල්පනා කරන්න පුළුවන් අය. මේක දැන් අපි අරකට කරානේ ඒකම තමයි කරලා තියෙන්නේ. So the invalid scenario is 0 0. දැන් අපිට කියන්න පුළුවන් I 0 0 invalid කියලා. Remember when at least one value is 0, output is 1. This is 0, output is 1. This is 0, output is 1. ඔන්න දෙකම 1 වුණා. ඕනනම් මේක අර logically එකේ දාලා දෙකම 0 කරලා බලන්න දෙකම 1 වෙනවා. දෙකම 1 වෙන එක පාට. මේ 1 වෙනවා. හරි. So again if you want you can go for gated SR latch. Gated with enable. So there you need 2 NAND gates again. එච්චර නම් අහන්න ගන්න නෑ. හරි? Just remember SR latch, right? Gated SR latch, D latch, gated D latch, and simple S bar latch. S bar වල gated ගැන හිතන්න යන්න එපා ඔයගොල්ලෝ. හරි? Make it for your information. Okay. And again, if you want, you can make a D latch using S bar latch because S bar latch is pretty much like SR latch. එකම input එක දෙන්නටම දෙන්න. පොඩ්ඩක් මේක දැන් gated කරගන්න පුළුවන්. Right? Whether it's you create your D latch using SR latch or S bar latch, it doesn't matter, right? Again, the idea is Q follows D. When D is 0, Q is 0. When D is 1, Q is 1. You can see when D is 1, Q is 1. D is 0, Q is 0. So that D latch behaves exactly the same way. Whether it's built using SR latches, SR latch or S bar latch. Or whether you build it using NOR gates or NAND gates. මොකද මම gated කරාද ටිකක් තව complicated වෙලා යනවා ඉතින් හරි මොකද කලින් gate කරේ AND gate දාලා දැන් gate කරේ මොනවද NAND gate දාලා හරි NAND gate දාලා gate කරා right that's it about latches හරි හරි ඊළඟට කියන්න ඕන flip flops කියන්නේ මීට වැඩිය අමාරුයි දැන් ඔයා ඉන්නේ එක තලයක නම් ඊළඟ තලයට ගෙනගලා තමයි ෆ්ලිප් ෆ්ලොප් තේරුම් ගන්න පුළුවන්. මේ තලේ ඔයගොල්ලෝ තේරුණා නම් හොඳයි. මේ තලේ තේරුච්ච දෙයට ෆ්ලිප් ෆ්ලොප් තලයට තකින්න අමාරුයි. හරි. දැන් මෙතන ඉන්නත් දන්නේ තාම ඩිකෝඩ් එක මල්ටිප්ලෙක්ස් එක තේරිච්ච නැති ඒක වෙන තලයක්. ඒ තලයට වඩා මේ තලය ලොකුයි උසයි. මේ තලයට වඩා ෆ්ලිප් ෆ්ලොප් තලය උසයි. flip flop කාලේ උසාවි. So if you need more exercises, maybe you can ask ChatGPT also. ChatGPT අඳින්න බෑ තාම. හරි ChatGPT ඉක්මනට චිත්‍ර අඳින්න පුරුදු කරන්න ඕන. Say MCQ questions on SR and D latches. Yeah, questions tiga කරන් තනි. मैं question tiga කරන් නිකන් ඉල්ලලා අතලේ කළා. Questions. Flip flop යාදාම් කරන්න යන්න එපා හොඳේ. Okay, pin. මේක තියෙන ඔක්කොම ආඩ කරන්න බැරි වෙයි යා. ඔක්කොම ඉලෙක්ට්‍රොනික වල ටිකක් දරුණුවට කරන සමහරට මේවා නම් අර ලේසි වනේ මේක. Yeah, SR latch consists of how many inputs? ඒවා නේ නිකන් පුළුවන්. The full form of SR latch is system rated, set reset, set ready, set rated, it's set reset, right? එවන නිකන් කම්මැලිකමට අහපු question ටික අතර පින්තූර එහෙම නැති ඒවා. ChatGPT ට කිව්වොත් බලමු. ChatGPT පින්තූර ගන්න බෑ තාම යාර. That is ChatGPT. Generate 5 MCQs on SR latch and D latch circuits components. හොඳ question දෙන්න පුළුවන් ඇත්තටම මේ diagram එකක් එක්ක හැබැයි. හරි එයා දෙන text question එක අන්න හරි. See the main difference between SR latch and D latch is okay. So in a D latch, if D is 1, the clock enable high, the output will be. වැඩි දින මට පින්තූරන් දෙන්න බෑ. තව මාසයක් විතරකට පින්තූරන් දෙයියා. Right. So we'll take a small break. After the break, we'll move on to programming.